So the Pockels effect experiment will demonstrate today. Is it visible, right?
Yes, sir.
Yes, sir.
Okay. So this is the laser source. This is helium neon laser source, and it is linearly polarized. Okay. The wavelength is 632.8 nanometer, and here 5 lens is there, and here 50 lens is there. Okay, so the laser beam is coming here through these lenses, and it is incident on the cell, Pockels cell. So Pockels cell is lithium niobate. Okay, and so it is incident. The laser source, the laser light is incident through these lenses, and it is incident on the Pockels cell. So it is lithium niobate. So here the polarizer and the cell is attached here. So the cell is there. It cannot be visible. So the cell is there, and a polarizer is also attached here. Okay. Now the light is incident and the optic axis is perpendicular to it. Okay. So this is transverse configuration, and due to this, uh, and this is the analyzer. So after going through the focal cell, polarizer, and the analyzer, it will the light due to the E ray and O ray due to the birefrangences of the focal cell. So it is getting interfered, and interference, due to the interference, some interference pattern will see. So I'm switching off the light in the room, so you can see the interference pattern. So it is basically two sets of hyperbola, right? Is it visible? It is very difficult actually. And the sole part of optics experiment is the alignment. Is it visible? The pattern is visible.
Yes,
Yes,
sir.
sir.
Yes, sir.
So it is visible, right? So two sets of hyperbolas, hyperbolas is there. So one is rotated 90-degree with another. Okay. So one set of hyperbola is 90-degree apart from the another. Okay. Now I am rotating the analyzer, and making the and changing the angle between the polarizer and the analyzer. So we can see the changes in the pattern, right? So it is, now we cannot see the hyperbola. Now it is become clearer and clearer, and the intensity is also changing, right? So in the intensity is reduced now, and again the intensity is increasing, and now it is become a vague, right? So are you able to observe the changes? So what I'm doing, I'm just changing the angle between the polarizer and the analyzer, and see the pattern of the in the screen, and how the intensity is changing. Is it visible?
Yes, sir.
Yes, sir.
Okay. Now we'll make the angle of the analyzer and polarizer at 45-degree. Okay, almost 45-degree. So this marker is now at 0. And this marker is at 45, right? 35, and the differences of the of each marker is 15. So for 30, the middle between 30 and 60 will be 45. Okay, so this marker is at 0 and this marker is at 45. So the angle between the polarizer and the analyzer is now 45 degree. Now we'll attach the we'll switch on the power supply. So it is in the order of kV, kilovolt, and we have to make sure that it should not exceed 2 kilovolt. Okay. Now we'll increase the voltage. We'll increase the voltage and see the pattern. So I'm increasing the voltage gradually, and you can see the pattern is changing. So the voltage is now 1.9 kilovolt. Okay, so we'll not increase further. Will not increase. So the voltage we cannot exceed 2 kilovolt. Okay. Now again we are decreasing the voltage gradually, and the pattern is changing, right? So with the applied field, applied electric field, the birefringence is changing. So already the Pockels cell was negatively birefringent, and after applying the voltage, it is getting modified. So in Pockels effect, we have already discussed that when there is no birefringent in the medium, then the birefringent is induced, and when in the cell some origin the birefringent pattern is there, then the birefringence is getting modified after the applying field, and the electric field E is proportional to the it is linearly proportional to the changes in the refractive index of the E ray, extraordinary ray, and ordinary ray. Right. Now the final part, we have to mark a point here. So I'm marking here. And now we'll increase the voltage. And we'll see the pattern. Now we can see when we marked the point, it was at the it was in the bright fringe, right? Now it is in the dark one. So some phase change happened, some pi phase change happened. So this voltage, and the voltage is 0.6 here. The voltage is 0.6 kilovolt here. So with the application of the 0.6 kilovolt voltage, due to this electric field, the phase change of pi occurred in the birefringence, and the dark fringe, the bright fringe has become now the dark fringe in this at that point. Okay. So now if we increase the voltage further, you can see that in the mark some bright fringe again here comes. Okay. So now again a change of pi phase change occurred with this application of the electric field. So it is the voltage is now 1.1. So at that point the voltage was 0.6 and now here it is 1.1. So 0.5 is the half voltage, half phase voltage. We further increasing the voltage and see now here again dark fringes are there in the marked position, right? So the voltage was 1.1 at that time when it was a bright fringe. Now it is a dark fringe at that point and voltage is 1.7. Now the half pi voltage is 0.6. Okay. So we have to average out the half phase voltage. Okay. So we can see here the due to the application of the electric field, the birefringences changes with the applied electric field, right? So the three parts are there in this experiment. One is alignment of this setup. So we have to align the laser light so that it comes properly, and it is not fully aligned, I must say. So if you give more time here in the alignment, the more accurate result you will be getting. Okay. And then you have to observe the interference pattern. So the interference patterns comes due to the E ray and O ray. The E ray and O ray getting interfered, and here in the screen we are getting interference pattern. So we have to observe the changes of the interference of the birefringence with the angle of the polarizer and the analyzer, and we have to mark the optic axis in your lab book, and finally we have to see how the applied voltage is modifying the birefringences through the Pockels cell, and finally we have to measure the half pi voltage. Okay. So any question? So we are now decreasing again the voltage. We can change the angle. So we have changed the angle, and now we are applying the electric field. So it is getting changing, right? Here also it is getting changed, right? So if there is no further question, we are closing the session. Thank you.